Hi guys, I'm home now, so I only have my document camera here, but let's keep going with this. Okay. Alright, so last time we figured out how far the vehicles traveled in a 2-hour time span, and now we're saying both cars pass a gas station 120 kilometers from the school. When did each car pass the gas station? Okay, so we're kind of changing our x final now. Now we're saying how long does it take to get to this x final? So now we know x final, but we're solving for t. So let's rearrange this equation so that we're solving for time. So first thing, whenever you encounter an equation that you're rearranging, I want you to take a moment and say, okay, here's my unknown, this is what I'm solving for, and if there's anything added or subtracted, we should move that over first. We should take minus x initial to both sides of this equation first. Because if we do that, then we have x final minus x initial is equal to our average velocity times by t. And then we'll divide by that velocity to get our time there. So time is going to equal x final minus x initial divided by velocity. Okay, and so we're going to take this equation here and we're going to plug in these values for car A and car B. Okay, so we have, again, two cars leave the school. Car A is traveling at 75 kilometers an hour. Car B is traveling at 85 kilometers an hour. Okay? So for car A, time is going to equal x final, which is our 120 kilometers, this distance from the school, because we said our school is our initial, so we're calling that 0, minus the initial, so minus 0 in this case, okay, and divided by velocity, which for car A is 75 kilometers an hour. Okay. So when I take this 120 divided by 75, I get 1.6 hours. Okay. Now let's look at car B. Car B, we're very similar. We have 120 kilometers is still our final. Our initial is still 0 at the school, but our velocity is different. Now we have 85 kilometers an hour. And so when I plug this in, I get 1.4 hours. Okay, and notice I'm working with my sig figs here. Like I have 2 sig figs, I have 2 sig figs, so my final answer is 2 sig figs. Okay, now, next equation here, some of these values are going to change. So we have 2 cars are traveling to the beach, which is 50 kilometers from school. At noon, car A leaves a store that is 10 kilometers closer to the beach than the school is and moves at 40 kilometers an hour. Car B starts from the school at 12:30 and moves at 100 kilometers an hour. When does each car get to the beach? Let's draw a picture of the situation that we have. Okay, so we have the school, okay, and we have the beach over here, and then there's also a store, right? At noon, car A leaves a store that is 10 kilometers closer to the beach. So we also have some store. And let's keep our school as that initial, our 0 point. And we have car A leaving from the store, and they're leaving at Car A leaves the store. Oh, at noon, right there. At noon, car A leaves the store. Okay, so at 12 p.m., that's when car A leaves. Now, car B leaves from the school, and car B leaves at 12:30. When does each car get to the beach? So we're looking for time again. So let's take that same rearranged equation. We said that the time is equal to x final minus x initial divided by velocity. Okay, and so for car A, our final position is the beach, which is 50 kilometers away from our 0, point, right? And its initial position was at the store, which was 10 kilometers away from our 0, point there. And then the velocity of car A is 40 kilometers an hour. So we're going to take 40 kilometers divided by 40 kilometers an hour. So we'll have 1 hour. Okay, and then just a reminder, they left at noon, and so they'll get to the beach at 1 p.m., right? An hour from when they left. So get to beach at 1 p.m. All right, now for car B, our x final is the same. It's the beach that's 50 kilometers away from our origin. And our initial position, well, the car B started at school, and so that's our 0 point, that's our origin. And they're traveling at 100 kilometers an hour. Okay, and so that means I'd have 50 kilometers divided by 100 kilometers an hour, or 0.5 hours. And again, just a reminder, they left at 12:30, and so they're going to get to the beach at 1 p.m. as well. So they get there at the same time. Nice. Okay, good work, guys. So here, this is just a review of the equations that we've looked at today. So we know that delta is final minus initial, and that this applies to time. We can look at the difference between position and displacement. And then we have this equation, 2 equations really. Sorry, you can hear the doggies. You can see these 2 equations that we were working with today. Here's average velocity, and then here's position. That's my dog, Lucy. Lucy, stop. Anyways, so those are the 2 equations we worked with today. All right, guys. Good work. Keep it up. Email me if you have any questions.